All right, let's kick on. This next section, ISMS Operations. So just a quick recap, we've really done the planning side. Like with all things, planning is a good thing. You know, in a way, the better the planning, the more likely these things on the right-hand side are going to perform optimally for you. We've done the governance, leadership, and commitment side. So we're going to spend the rest of the afternoon here in operations, evaluation, and a little section at the end on improvement, and a small piece here on these parts. But let's look now at this operations. The way the standard does this is a little bit weird. It seems backwards to me, but anyway, it's the way it is. It has section 8.2, which says you shall perform scheduled risk assessments. Periodic, event-driven, anything like that. So you need to set some kind of operational calendar that says how often will you do risk assessments, risk identification, risk evaluation activity. And it also says when you've done that assessment, you should plan to implement the treatments that come from that. And those two pieces, to some degree for me, precede the operational planning and control, because this helps me know what I need to plan, that I need to put in place. Some of them will be mitigation strategies. Some of them will derive from where I've done a risk assessment and I've identified a control that needs improvement. And on top of all of that, we need to do what says here, operational planning, the implementation and execution of a whole raft of controls that need implementing and operating. The question, I guess, is how do we arrive? How do we know what they are? And the answer to that is risk assessment. And I saw, and I think it was Steve's comment, that risk is subjective. It's kind of subjective throughout. I think risk management as a global kind of profession is done okay. I wouldn't say it's optimally done all over the place. I think we see a lot of risk methods which are quite light on, risks which are not defined very well, with risks which are evaluated kind of clumsily, if you like, or without sufficient data to drive the right level of likelihood and consequence. But in the end, we kind of, it is what it is. We've got to use what we've got. So the idea here is to make the most of using the risk method as best you can to arrive at some knowledge that will help you with planning. So picking up that model that we would have created earlier, or hopefully used an enterprise risk management model, the task ahead is to identify risks. And essentially, it requires us to be able to craft up a risk statement. In the end, we need these risk statements because these are the things that we're going to manage going forward. And how do we do that? A method like this kind of works okay. So remember my top-down, bottom-up from prior to lunch. If I was to categorize or maybe describe it using the right kind of descriptive to arrive at the risk scenario, I would identify some kind of event, positive or negative, the causes or threats to that event, or caused by that event, sorry, and the resulting impacts of that event, and that would create a risk statement. So the risk of unauthorized access to sensitive information caused by phishing attack and user account compromise, resulting in data disclosure. The reason this kind of aggregated logic here is useful is it allows us to look at either the what or the how and the impact statement, so we can perform mitigation on a range of things, likelihood and consequence, or a bit of both, control uplift, maybe trying to avoid this scenario in the first place. So it helps us to be able to then work out a strategy to mitigate the risk. There's a couple of states of risk that are important to understand, and basically they are inherent risk, which is typically described as the level of risk without taking into account any controls or any risk response, no mitigation strategies. Now, this theoretically is risk with no control. But it's quite complex and difficult and hard hypothetically to think of circumstances where there are no controls at all. So a model that I use to overcome that hypothetical problem, and perhaps to make it a little bit more real, is to say, what is the risk if all or most of the key controls fail? And, as an example, when I think of inherent risk of, say, plane crash or flight, an accident in flight in an aeroplane, if I take out all the controls, then the plane's not getting off the ground. So what is the catastrophic level of inherent risk in flight? Probably some kind of, problem with the plane that causes it to crash. Now, what would be all of the controls that would need to do that to cause that level of risk? That's kind of, not a hypothetical situation now. It's useful for me to work through. So you might want to use this in a way that helps you comprehend what the inherent risk is. There's another reason we want to do this, and I've seen risk implementations, risk methods that don't have inherent risk. But inherent risk is quite useful, and I'm just going to slide the cursor, the slides back. Inherent risk, if I assess the level of risk without taking into any controls, and I plot it, I'm probably going to be rating inherent risk up here in this high mark. And it may be a little lower, but if I rate an inherent risk up in this red zone, then this risk probably, just by its impact to us, is likely to be one of those risks where I definitely want to lower it down to an acceptable level, and I should then monitor those key controls that keep it down there. So the idea behind the benefit of identifying inherent risk is it helps you now know which are the worst case scenario risks that you really must keep an eye on. And when you're reporting risk, so if you're reporting risks to your leadership team, the two basic risk types or risk information types that I'm reporting, one is the risk treatment plan and its status. In other words, how are we going fixing the risks that we know are not acceptable? But also this one around inherent risk. What is the current state of inherent risks, and how good is the current control environment today to keep it down low? So just something to think about from a reporting perspective. So current risk is the actual risk today, inherent risk with our current risk response applied, risk with the current control framework that we've got. And then residual risk might be any additional risk responses we want to add. This might be a future state to say that today the risk is moderate, medium, whatever. But when we implement this new method of treating this risk, the residual risk then will be low. Once that thing is implemented, my residual risk equals my current risk, so I don't have any future state risk to worry about. Now, so that's essentially the three states of risk. Just on this though, I've seen definitely a different language. That's what I was after. I've seen different language used to describe these. I've sometimes seen current as residual. I've seen target risk as residual. So these words are not universally applied. You can choose whatever words, as long as you understand that there's risk with no control or it is all bad, current state where we are today, target state where we'll be when we fix things, are the three basic positions. Now, here's this 5-stage methodology we saw with ISO 31000. This is the typical model that we would implement. Identify, analyze, evaluate, treat, and then monitor with the right kind of governance and oversight around this cycle. We've added this other model here, which is a little bit like the VPDSF in Victoria model, where it's more based on identifying and valuing information assets. Say it might be the things we identified in our PARI workshops, then identifying the risks to those using whatever model you like, top down, bottom up, etc. Assessing and evaluating the level of risk, prioritize and treat and select the controls, monitor and manage. It's the same 5. It just puts a little bit more, I think, meaning to these terms. But it does use a sort of information asset model. You can use this top-down model approach as well. This is essentially understand your context and then identify the risks from that context using whatever method you can to come up with the key risk scenarios that you want to work on. So this is a reasonably straightforward approach. So this is the sort of thing you do at, say, a beginning of a project to identify security risks as you build something, go into the build or the acquire phase. It's the sort of risk assessment you might do on a periodic basis. You might do this with a business function to just start off a risk assessment. And, these kinds of sources of or issues down the bottom is the guidance to help you through that. I've included this model as well. This diagram we took from the OVIC, the Office of the Victorian Information Commissioner. They have a document called their assurance collection. The OVIC used this bow tie, and they had quite a neat implementation of this. You can find, sorry, you can find this out there. There's some other guides and documents around the use of this model. This is actually quite powerful if you can identify, say, a series of causal events and that would create a particular risk, and then look at the control framework that you have in place that's preventive. Have a look at the control framework that you have that corrects that aims to reduce these consequences and impacts. This one is quite useful because what you can end up with is these causes and effects may then lead to cascading risks. In other words, if I have, for example, just trying to think of one, if I have, for example, a loss of key staff, that would cause a system processing error, that might cause system downtime, the impact being loss of service to customer. But that impact, loss of service to customer, might then lead to other risks like financial impact, compliance impact, reputation damage, if I can go that far. And so you get this model where these bow ties cascade into each other. And what typically happens is you end up, if you picture that as this connection of bow ties, probably at least just 2 levels of them, one leading into a second. What you end up with is probably about 5 or 6 key risk scenario events that no matter what happens in the broad list of causes, the impacts are probably only about 4 or 5 key impacts for your business that create the catastrophic risks for you, which then just sort of backs up what I was saying about inherent risk. That inherent risk is typically the catastrophic failure of a substantial part of your control framework. Major outage, major data breaches are all often to do with a fairly catastrophic failure of a couple of key controls at least. This model might be useful for you to have a go at to explore it. It is a little tricky to use it, but it's quite powerful, and I've used it a few times reasonably well. So when we've done our evaluation, the end state that we're coming to arrive at is to make decisions on whether the business accepts the current level of risk for each of the risks we evaluate. We want to make decisions on what type of action to take where it's not acceptable, and then we want to prioritize those actions. So these are the 3 key decisions here. In this workshop today, we don't have time to do this, but I'm thinking maybe in future workshops, this is the kind of thing that we could probably break out into perhaps your organizational units and just start exploring this if you haven't already done it, either using the top-down, bottom-up model or any of these other models that I've shown you. So today I'm not going to go through a process of actual workshopping this. I'll just do the kind of theory and discussion piece at the moment. Okay, so we've done risk evaluation and we've determined treatments. If we were to capture this in a risk register, this is typically what it looks like. We have some fields around risk identification. There may be a half a dozen fields here. In a top-down model, you could connect it to a business goal or objective, and that would allow you to filter or search or aggregate based on that objective, which is a really useful thing to do. You probably want to have risk ownership in there. You might want to have business unit or system or asset in there as well, just so that you can sort and search on these to find which risks affect what part of the business or what asset or whatever. You'll notice that in doing that, though, this becomes a little bit problematic in a spreadsheet, and you probably need something like a risk register, or sorry, a risk database, a risk tool, because for each of your risks and each of your current controls, these are many to many. For each risk, you might have many controls. For any one control, it might mitigate many risks. An obvious example being access management is probably going to mitigate a high number of your cybersecurity and InfoSec type risks. Equally so, things like cryptography and incident response as a corrective control. So the second part of the register, the risk analysis part, you'll notice these map the 5 steps. Risk analysis, capturing the inherent risk, likelihood, consequence, and inherent risk rating. The current control, whatever documentation you need there, maybe in detail, maybe just summarized, maybe a single statement. And the evaluation of its current effectiveness. Because for each control, they're implemented to a different level of quality. And that could mean that the current control framework is not very effective just yet, and that's where the improvement is. Or it could be that you're missing current controls, and that's where the treatment lies, that you want to add new controls rather than fix them. So current controls, the last part of this part 2 analysis is to document the current risk status, likelihood, consequence, current risk, and then your evaluation. Does it meet our risk appetite, our risk criteria for acceptance, yes or no? And if it doesn't, what's the treatment? And if we're going to treat it, do we need to monitor the treatment? And if it's back up here in this high inherent state, if it's a high inherent risk, I would recommend also you consider risk monitoring for it. Monitoring that these current controls are keeping this high inherent risk to an acceptable level. Because if these controls start to fail, this high inherent risk becomes a high inherent incident and impact. So risk monitoring, we will look at risk monitoring through KRIs in the last section or near to last section today as well. All right, so that's the kind of data that you'll capture in your risk register. At a basic level, a spreadsheet does work for this. At a better level though, maybe some kind of risk tooling. I know Jira has some add-ons for this if that's your approach, but then there's other companies out there that are selling, good products in this space. There's a Perth company called Corporate Governance Risk. There's Protect as well, Protect. So there's quite a few, apps out there for this stuff. And so when you go through that process of identifying your risks, you'll end up with an inventory of risks, the risk register. Typically in the risk register, I wouldn't capture everything until I'm satisfied we've probably documented the right risk, we've got the scenario right, and that when we do the evaluation of it, it makes sense that this is a risk. We don't really want to capture every possible nuance of every risk scenario, or else your inventory is unworkable. My worst case scenario is I saw a risk register with 1,100 risks in it, and I think that's just mental. I think that's just unwieldy and unusable, and it suggests that nobody's read the first, 600 or 700 for a year or more. It's quite crazy. An optimal amount might be 20 or 30 or 40. I know one of my clients had 9 risks, and that was it, just 9 key risk scenario for their business, and they did a reasonably good job of maintaining that and using it effectively. So there's no limit on number of risks, but there probably is a limit on its usability as you get to a certain point. The other angle, the other side here is the control inventory, and we're about to move into the control domain. So back here, you'll notice in current controls, part of the analysis of risk is to identify what are the current controls that keep this risk under control, hence the name. And so you'll create an inventory of these. Within an ISMS, that thing is called the statement of applicability. And I have a slide, an image of that coming up in a couple of slides, but I just want to talk about controls just before we get to that. So let me just briefly, and Jason, maybe I could have added a slide here. Sort of the question is, what is a control? A control is something that safeguards an asset at the basic level. That's the basic definition of a control. Something that operates to safeguard an asset to, and I'm going to use these words now, prevent, detect, or correct something from going wrong that would impact the asset that it's protecting. So we can categorize our control framework. My aircon just went berserk. We can categorize our control framework into controls that operate as preventive controls, controls that operate as detective, and as corrective. So controls of preventive are designed to discourage or preempt errors or irregularities. And here's a bunch of them. There's hundreds to choose from. Detective controls are designed to find errors or irregularities after they have occurred, or sometimes even at the moment they occur. And there's some examples there. And corrective controls aim to mitigate, lessen, or reset the effects of a failure once it's occurred. Now, whenever we look at risk, we probably want for each risk scenario a collection of preventive, detective, and corrective. That it's typically not good enough just to have, say, detective and corrective controls. What that is saying is, whenever we get an incident, we'll deal with it, but we're not going to stop the incident from occurring. So that'll increase the cost of the way you do business by waiting for the problem to occur and then dealing with it. So in almost every circumstance, you need to have some prevention. And if you think about what your suite of preventive controls are, it does include things like policies and procedures. And as we've got here, things like awareness training, segregation of duties to stop people from doing things like collusion and fraud, firewalls to prevent certain bad traffic or bad things arriving in the zone, the network that you're protecting. Approvals, the approval that says, yes, this transaction is okay to go ahead. Access control that does things like least privilege or need to know or role-based. That prevents somebody having more access than they need and therefore causing a problem. Locks physically and logically, physical boundaries, antivirus, and the list goes on and on. I'm sure you can come up with a lot more than just that. Detective controls, things like intrusion detection, scans, audits might be a detective control, probably a little bit late unless you're operating things like sort of real-time auditing, what's called continuous controls monitoring. Antivirus, which may be detective. Antivirus may be preventive in that at the boundary, it detects bad stuff before it lands on a device. But there may also be a need for it on the device to detect when the malware has arrived on the device and it's already infected or it's about to or whatever. Motion detectors, fire alarms, all of those things. And lastly, corrective. UPS, so power, uninterruptible power supplies, which kick in when power has been lost to give power back. DR plans, backup. In fact, I probably would add on the end of this, in a way, a backup is a data file. The corrective control is the backup restoration process. HR disciplinary process, incident response, root cause analysis, corrective management, a whole bunch of things there. And so if you remember the comment I made earlier, you need to balance the investment you have in your controls depending on the risk and the asset value. Remember, I did that right at the beginning this morning. And so this is an area where you get to be more granular in choosing how much control is enough and what types of controls do we need and which types of controls are we missing, and is that the problem for us? Because typically when we've got an incident, one of our preventive or detective or maybe even corrective controls has failed, and that's the issue that we need to work out. How do we prevent it, stop it from failing in the future? So you need to understand controls. Annex A in ISO 27001 is a list of controls. I'll show you that annex in a bit of detail in a moment. There are other control frameworks out there, which I'll show some of those too. The second part I wanted to talk about with controls is this, that when you're looking at how you document your risks and controls and how you evaluate whether they're working or not, consider them from these two lenses. Firstly, is it designed that it will be effective if implemented the way it's designed? In other words, is the architecture of this okay? And here are some attributes to help you work that out. Firstly, that it's suitable for its operating context. Now, an obvious example of ones that have never been suitable for their operating context, but we keep using them, is passwords. Passwords were never suitable as a method to prevent unauthorized access because they're inherently weak. No matter how strong we make them, there's a new way to bust them. So design effectiveness, they probably fail that, which is why we use MFA and add-ons and other methods as well. Another design effectiveness is that it's robust to withstand error or misuse. Passwords, again, fail probably that, in that I might share it accidentally. I might type it in a way you can see it. I might store it on a piece of paper beside my desk. Another one is that it operates effectively within the overall process design. The worst case scenario against this one is where you create a security checkpoint which steps out of the process into some other activity and then comes back in. The reason that's not a good effective design is because, as you'll see over here, it will probably at some point then be avoided or circumvented because it takes time or it causes me to step over here. Can I give you an example that really annoys me? Multi-factor authentication. Every time I go to log in, I've got to switch over and find my MFA token serial number and come back in and then key that in. And sometimes I go there and key back in and I'll miss it. I'll go back again. In a way, we're kind of still in this space where our authentication mechanisms are annoying for a lot of the user base because we haven't solved design effectiveness yet. Efficiently achieved its goals. In other words, it's cost effective, that we're not spending too much money because we don't want to spend too much money to protect an asset that's greater than the cost of control. So the cost of the asset shouldn't be worth less than how much we put into protecting it. And then lastly, it ought to be repeatable. And it should be likely that the users will consistently apply it. Now, I could document it, I could train them, I can show them, and all of those go into the design effectiveness. Because once they've then got all that knowledge and this control, they then need to operate it effectively. And so operating effectiveness is that the control performs its objectives all the time. In other words, every time somebody uses this control, it achieves its objective, that it's not being avoided or circumvented, that there's no workaround for this, that they have to step through this control, that it reliably operates in all conditions, peak periods, junior staff, untrained staff, stressful times, Friday night at midnight versus Monday morning at 9 a.m. Reliably operates. If it doesn't reliably operate, it's not repeatable. And lastly, that it is executed in the way that it was designed. So if we write a procedure, is it operating the way the procedure says? So when you do the risk assessment back here, and you're looking at your current controls, what are my controls and are they effective? You're essentially asking the question, have they been designed to be effective? And are they implemented in a way that is as per design and is effective? Because when one or two of these fail, that's when you get the control falling over. So keep that in mind. That's probably a little bit of technical detail there for you. The last point here was this SOA, and I don't have a better picture of one, but here's what it would look like. Here in the first two columns in this one are the controls themselves. I've filtered this. There's a filter on in this one. This is just the category, and underneath this would be A12.1.1 and whatever else number of controls. And is it applicable to the standard? Sorry, is it applicable to my context? Is this control applicable to my scope? Is what this is asking here. If it's not applicable, then I don't need to worry about it. But if it is applicable, why is it applicable is important. What's the rationale for its applicability? And there's probably only 3 or 4 rationales that make sense. One is, and I sometimes don't put rationale, I just put these in. One is there's a compliance obligation. If there's a privacy act that you have to comply with or a legal requirement in a contract and the control is stipulated, then contractual obligation would be the reason why it's applicable. Another one is risk. Now, this one has a risk register. I don't really like this model because it's many to many. And I don't want hundreds of risks or 10 risks listed here or 5 or whatever. But a justification is simply that this control mitigates one or more risks. And that's the reason why it's applicable. There's a couple of others you might think of, but they're the main ones, that there is an obligation to perform it, that there's a risk if we don't, and then maybe there's this one that the customers expect this. Service availability, remember those stakeholder things. Now, in your ISMS and your statement of applicability, there are 114 controls across 14 categories. And so you need to, if you're going to follow the model, probably evaluate them all. There'll be some that you can deem as not applicable. And if you're going for certification, which you probably are not, you would also need to justify why it's not applicable. But if you're not going down that path, it probably isn't all that critical that you don't. Some other bits and pieces, who owns the control, a description of it, what does it look like? You might want to change this around. Maybe you just put referencing to procedural documentation rather than a narrative or a text description. An implementation status. This is actually really powerful here, because if I can document here, if I document here the status like this one in development, I know I've got to have an improvement item for this. This is going to come out of here, or it's going to stay here, but it's going to lead me to create something in my program of work to fix this. And if I need this control and it's not there yet, then I've got to do something about it. We added here documented and operational. You'll see these ones say, this one says documented, these ones don't. You can come up with whatever status you like. We have a bit of a model that we use. It's something like documented and operational. As you can see, the operational, in development, non-existent, not doesn't exist or something like that. And lastly, if you're going to call out improvements, you might want to put those references there. I'm not sure why this one or these ones have references, but this one definitely would need improvement, so away you go. Now, that's probably the minimal amount of content for a statement of applicability. You can use these for really useful things as well. Let's say, for example, we take the Tassie cyber policy and we put that as one of these justifications. And let's say there are specific expectations and you can map them to these controls. Then if over here your implementation status is in development or non-existent, and it's a required Tassie government policy control, then you can filter on this really quickly. You obviously need to keep it up to date though. You can do the same, and I've done this in New South Wales for Essential 8, but also their cyber policy. But I've done it for a lot of private sector businesses on things like privacy obligations, because there's a known list of privacy requirements. And if privacy is your thing, then you need to comply with them. And by knowing that we've got a bunch of these that are not implemented effectively yet, that's like just calling out, hey, we're non-compliant and we know that, let's fix this problem. And so there's a nice and easy way to see the control gaps from a regulatory or a customer service or a contractual perspective, just simply by putting these filters on and using these rationale or this justification column in a rather more effective way than just say risk referencing or a text-based rationale. So you can get power from this. You can get power from it. You could also do it by a system, for example, or customer service. Imagine if you had this by business unit. Let's say, I don't know, let's say you service many customers as an agency. You might put different customers and their expectations here, and which of the controls meet their requirements, and therefore what's the status. And for those controls that meet the most number of customers and have the biggest gap, that possibly maybe is your priority for improvement. And I guess conversely, let's say if I have, 5 customers here in my justification, and I have 5 ticks or yeses for that, and I count all those controls that are essential for every one of our clients, then they are now key controls. They are now the most important controls, because without them, we would fail our customer service. And if we fail customer service, there's no point in being here as a business. So there's a number of ways you can play around with this to get better or to optimize it for your data, for your needs, for your program. Did just any questions on
Kevin's
that?
Kevin's got someone in the chat there.
Oh, okay.
You just mentioned about passwords and a fixed versus, rather than being a fixed control, how do we implement, document a progressive control, say passwords stepping into MFA, stepping into zero trust?
Yeah, look, I don't know that I have a great answer to that. I think my concern with passwords and even MFA is for a lot of the user base, and if I consider citizens of Tasmania as users of your systems, as you move towards portals and you customer access into systems, you're kind of stuck with some method of authentication. And Kevin, I think it's great that you've called out that you need to move forward with better than password controls, because passwords are just done their day. They're like just an opportunity for breakage. MFA, stepping towards that, you mentioned zero trust. I think some of these are really cool architectural design choices you need to make, because I think, like I've said a few times, we sometimes make controls that are usable for us. And my problem with passwords is this: the longer you make them and the more complex and the more frequent people have to change them, the more likely they are to share the same password over and over or to write it down. And both of those are the things we're trying to avoid anyway. So we've got to find ways to make it easier for customers to log in. MFA and one-time passwords and text-based one-time passwords, all those things are kind of the next step down the path. I get that. I don't have a better architectural solution, but I think you're right to call it out as something that needs improvement. But I don't know that we have a great control. Biometrics have their downsides too. And as Tristan pointed out, this is a pain point. And Tristan, this is my reason for calling out passwords. I'm not talking about it from an IT perspective. From a user perspective, passwords are rotten. They always have been and they always will be. I wrote a paper, I presented at an audit conference in 95 or 6, saying passwords are the bane of security. And we haven't resolved that problem. I don't have a solution maybe zero trust. Kevin, did you want to chip in on that? Maybe moving to something like that and better authentication, maybe zoning the systems and applications so that we can have stronger control for some user base, but more open. Say if you're dealing with, I'll call out my mum here, 80 something, and doesn't know how to use the COVID app and all of that kind of stuff. How do we get that group of users, 50, 60 plus, who are not digital natives to use it? And how do we build authentication for, I'll call out my daughters now, 15 and 20-year-old girls who are young women who are using the internet for all sorts of things. How do we coax them into authentication systems that make sense, that are usable? I don't have an answer. I can't quite hear you, Kevin. Is there a separate switch on your mute?
How's that?
That's it. That's it for the mic.
Yeah, so rather than passwords per se, I guess what I was saying is progressive controls over time. So where we've gone through and said, okay, our inherent risk is X, our target risk long term is something else, but it's going to be a step process on the way through. So where you've got an improvement register or various things there, do you have multiple lines in your risk register saying risk register at point in time A, at point in time B, at point in time C, indicating that it's going to be a walking feast over time?
Yeah, and you might have a multi-stage treatment plan. That's definitely what I've seen. I had one client who was required by contract to have data loss prevention. They couldn't do it, but what they did do was implement some fairly basic things early. And so their treatment plan was three-staged. And they said, we'll arrive at the acceptable level of risk in about 2 years' time, mainly for reasons of budget. That the full rollout of this was going to be arduous. So they just stepped through, the minimal and the most risky part first, and then built on it over time until they finally got to that state. And they kept a watching view on that. Whether we can do that with things like authentication schema and all of that, I don't know if you can plot a future path or just simply say, look, this method is as good as we've got at the moment. We recognize it's not perfect. So maybe, there's flags you could put on in here, to explore alternative architectures and designs. Or one thing I did, and it's probably a one-off in my career, certainly, we took away authentication and access control by just simply, as a government agency, publishing the data we were trying to protect. It seemed way too costly and complex to try and protect it. So we just published it to our website. And if you wanted to go find it, you could. That eliminated the whole authentication method that we're going to have to deal with. And, potentially millions of users trying to log in to get stuff when there was no way we could have controlled it. So sometimes it's maybe the thinking outside the box, but for some of these things, we're kind of stuck with the architectures and the tools we have today, or with the user base and you'll notice this word here, operating in context they have. If you're, say Department of Health, then you are dealing with patients who are from 0 to 100 and something. And if you're in, education, not TAFE. If you're in TAFE, it's adult. If you're in education, they're school age. So you just got to keep those contexts in mind in your control design. But there are going to be things where you just have to accept a level of risk because there's not a lot you can do just at this point. But yeah, so good discussion, Kevin. So I don't think I answered it, but I think you're right to call out a multi-stage. And, flag that with your leadership about how much risk are they willing to accept, knowing that these tools, these controls we're applying, particularly in the cyber sense, are breakable, then they're going to have vulnerabilities that somebody is going to find a way to exploit. And that's where I think cyber gets tricky. Does that help?
Yeah,
a little.
Yeah, it's like a continuum one. It's always the little that's there and how to build it in. Some of the bow tie ones are interesting when you see multiple causes where each one has a different control. That can be an interesting way of doing it as well.
Yeah, absolutely. The bow tie is quite a useful model to try and explore it. Yeah, thank you for that.
Yep.
Just moving on then. So here are some control models that are out there if you want to look at them. The COBIT model has a bunch of controls. There's a COBIT for information security. This is an ISACA product that is essentially, it historically means control objectives for information and technology. It's a management and governance model. There is the NIST cybersecurity framework, and I guess to be completely accurate, there is all of those NIST guides, the 800 series. There's some quite good stuff, but they're written for the US Fed government, and so they're exhaustive in their size and their approach to things. The payment card industry data security standard has a model in there as well, the DSS. The Cloud Security Alliance, a useful one certainly for cloud. ISO obviously has a cloud model that I referred to earlier this morning, the 27017 ISO standard. There's the SOC, service organization controls. May not be that relevant in your context, but it may be something to look at. It's a thing called the Trusted Services Criteria. It's just, if you like, another bunch of controls that may be useful to give you some alternate approaches. They actually have a nice little part that deals with application layer stuff. There's the Information Security Manual. I think I added a slide or two on that coming up. I did on the next little section. And probably one I didn't have on here, but I took it off because I wasn't sure many of you would be doing dev stuff. Things like OWASP and that kind of stuff. The whole authentication forums that are out there around open authentication and control frameworks for that. So there's quite a lot of control frameworks and reference material out there for you to look at. But right now, the basic one is the Annex A. And in ISO 27001, this Annex A, I always find after I eat lunch, it gives me a dry throat. This Annex A has a broad spectrum of domains. Here are the 14 domains: policies, organization, HR, asset and access, crypto, physical and environment, operations and comms, so IT ops, networking, if you like, systems acquisition and development, supplier, incident management, information security, business continuity, and compliance. And that's the 14 controls that are embedded, 14 control categories, 130 something controls that are embedded into the Annex A, or if you like, ISO 27002. These are in the process of being modified to just 4 categories. So it's going to change dramatically. But these are a base point. Those of you that, if ever you are looking to be certified, you do need to reference these. If you're not being certified ever, then you could pick this or any of the other control frameworks, like the ISM as an example. I'll show you that in a moment. The last couple of pieces here, just in operations, is documentation. Remember I said at the beginning, and it's essentially clause 7.5, we need to document. And how you do that is up to you. And the ISO standard has no requirement for volume, but it does have a requirement for what you should document. And there are some mandatory requirements. I think, Jason, they might come up in our documentation section. I'll show you what those mandatory documentation requirements are. But if you think about it at a control level, you essentially need to write procedures that look something like who, what, when, where, why, and how, and as an example like that. And it's an important point to document sufficiently for your reader, for your audience, for your control operator, so they know what to do and when, and perhaps even why it's important. Remember my start with why. If somebody knows why they do something, they're probably more motivated to do it. And so that why piece, I find, if you write in a procedure why something is important, this control ensures that we protect ourselves from cyber risk, or protects really valuable customer or client or patient or student information, or protects investment details about where we're putting our money or whatever it might be, then people are more likely to perform the control with that. The last piece just in operations is, and I realize we didn't dive into these Annex A only because with 114 controls and 14 categories, it takes around an hour or two to go through them in any detail. But you will need to create some kind of operational planning / security calendar thingy with a series of activities, maybe the reference to the ISO standard, the schedule, the frequency, the date, whatever makes sense, frequency, and then who owns this. Now, this is a table in a PowerPoint, but you might want to embed this into things like, those ticketing systems, Jira tickets, ServiceNow or Manage Engine type ticketing systems, even Outlook or Teams, to create appointments that people can comment in, like as a Jira ticket. You can create it, allocate it, comment on it that's been done, attach documents as evidence, and then close it. And using systems like that to more efficiently demonstrate that things that were supposed to be done got done, or that things that are on the schedule have got somebody allocated that's going to do it. Spreadsheets and PowerPoints like this don't ensure implementation. They just basically say, hey, these are the things we think we'll do. So try and find a way to implement this in an automated fashion wherever possible. There is a tool that one of my clients in the health space is using called ISMS.online that seemed pretty effective. I might explore that tool a bit more, but that's like an app, a cloud-based app. The issue I think you'll face with a number of these things, though, is they may not be onshore. They may not be even on Tasmania. They may not be on the mainland. They're quite probably clouds somewhere in who knows where. So that's essentially operations. It's basically just taking all of the tasks in our clause 4 to 10, but especially the clause 8, and just putting some plan and control over it, understanding the risks and treating them, and implementing and executing the controls that we need to have in place that are going to manage those risks. And the additional piece is the clause 4 to 10 stuff. As you can see, I've got some clause 4 to 10 and a little bit here on the Annex A, an A7 there and an A there and there. So some kind of planning tool is really helpful. Essentially, what needs to get done when, by whom, and how am I going to allocate it to them? So just thinking of another of my clients, they're in the artificial intelligence, machine learning space. They use Jira templates for all of their business activities. And that Jira template is where they take their notes, reviewed the user access for this system on this day. Here's the findings, here's the result. And then they'll create a sub-ticket to fix the issues, and then another ticket for the improvement on why those issues were problematic. And it's just all there. And you think, wow, this is just easy for me to look at and audit, but it's easy for them to find who's doing what and when and what are our issues and all that kind of stuff. So keep that in mind. That's probably a little bit advanced, but it's certainly a practical way to implement what can be rather onerous.